For level E of problem 1, we have to find how many permutations there are on this Rubik's Cube. To start, there are 3 different rotations for each of the corners. That's 1, that's 2, and that's 3. And there are 8 corner pieces. So that's 4 here and 4 there. So for this first piece, there are 8 positions that it can go into, which is 1, 2, 3, 4, 5, 6, 7, 8. And 3 rotations in each of those positions. So now that's 8 times 3 for this one right here. 24. Then for this next one, since this is already taking up a position, there are 7 of them. But still 3 rotations, which gives us 21 for the next one. And if we keep going like that, we will eventually get to 1 place for this very last one, and 3 rotations for it, which gives us 3 for the very last piece. But then this cube also has edges, and it has multiple ways of rotating them too. We can put it in like this or flipped. And there are 12 of them. That's 4. There's another 4. There's the last 4. That's 12. So for this one here, we have 12 positions. So 4, 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4. So we have 12 times 2 positions for this first one. Then we have 11 times 2 for the second one, because just like before, now this piece is taking up a spot, so we have 11 left, which gives us 22. And then we go all the way down to when we have 1 left. But, as most people know who have played with a Rubik's Cube before, this is not a possibility. So, we get rid of this one right here, because no matter how the rest of these are twisted, I can always compensate for that by twisting this last one. So if I just, I can always compensate by twisting this last one in the right spot. So now that is possible. Same thing with these. If I flip this around, then that's not possible, because it is not possible to have just one edge piece swapped. That's not possible. So, again, no matter how these other ones are flipped, I can always compensate by putting the last one in one way. So we cross that out too. Now, let's forget about the cube for a second, and let's pay attention to these dice. With these dice, I have 6 faces on each, so 6 numbers for each. And for each roll on this die, I have 6 here. So if this is a 3, I can roll a 1, a 2, a 3, all the way up to a 6 for this one. Then let's say this one is now a 1. I can also roll 6 here. So for each of these 6, I have 6 here. So to find how many total possibilities there are for this, I just do 6 squared, because 6 here, 2 dice. Now back to the cube. For these corners, I have 24 for this one, and for each of these 24, I can put this one in a way, in one of 21 ways. So, this one 24, 21, then this one 18 for each of these. So once we multiply all these numbers together, 24 times 21 times 18 all the way down to 9 times 6. And then I can also do the same here, because for each one of these out of 24, I have 22 of these. So I would do the same here. But then I would multiply these two sets together, because I have, so once I place all of these in, for each of the ways that I place these in, I can place these in this many ways. I can place these ones in this many ways. But we're not done, because after I assemble this cube again, I will show that there's another step to this. Now that I have the cube fully assembled, some people may know that something like is also impossible. You cannot swap two corners, leaving their rotation the same. You cannot swap them in general, because something like this is possible, but switching them back is not possible. So, in order to compensate for this, we can just divide this total number by 2. Because now for every single one of these, we have a new number. So, because now we have this much divided by 2 for possible, and this much divided by 2 that are impossible, because now that's a permutation, that's a permutation, this is, and so on. So we have double. Some people also know that something like this is impossible. But as I will show now, this is the same thing as having two corners swapped. Now 2 corners are swapped. And I did that just by turning, which shows you that they are the same thing. So we do not have to account when 2 edges are flipped. And once we calculate this here, we will get our result.